The manufacturing process of heavy machinery, such as Komatsu excavators, is a combination of precise engineering technology and advanced manufacturing systems, Komatsu way. The following are the key stages of its production chain. 1. Design and steel fabrication. Selection of raw materials. Komatsu uses high-strength steel to withstand high pressure. Laser cutting. Thick steel plates are cut with the highest precision by plasma or laser machines according to technical drawings. 2. Welding and structure. Robot welding. Key parts such as the boom and arm and chassis are welded by robots to ensure that there are no gaps and uniform strength. Ultrasonic testing. Ultrasonic testing is used to check the inside of the welds for air or cracks. 3. Core component manufacturing. Unlike some companies, Komatsu manufactures key components in-house, including engine, installed with emission-reducing technology, hydraulic systems, manufacture of pumps and motors, the heart of the excavator's powertrain. 4. Final assembly. In this stage, all components are brought together. Undercarriage installation, install the chain system and travel motor. Cab installation, install the control cabin with safety system and technical monitoring screen. Hydraulic system connection, install hoses and connect control circuits. 5. Quality control and testing. Before leaving the factory, each machine must pass performance test lifting weight and rotating the body, leak test, check for hydraulic oil leakage, and Comtrax system, install GPS system and remote monitoring via satellite. Engine manufacturing is one of the most complex engineering processes, requiring micrometer-level precision. For heavy-duty engines like Komatsu, the process involves the following key steps. 1. Casting the block. The engine block is the backbone of the entire engine. Melting. Steel or cast iron is melted at temperatures of over 1,500 degrees Celsius. Sand casting. Special sand is used to create a mold, and then molten iron is poured into it. Once the iron solidifies, the sand is removed to remove the engine block. Heat treatment. The iron block is placed in a heat treatment furnace to increase strength and reduce brittleness. Machining. This is a stage where high-precision CNC machines are used. Cylinder boring. Drilling the cylinder bore where the pistons will travel. The inside surface must be perfectly smooth. Drilling and tapping. Drilling holes for bolts, oil lines, and coolant lines. Milling. Grinding the top surface of the engine block to make it as flat as possible, to ensure that when the cylinder head is installed, it will be tight and will not leak air or water. Fabrication of components. At the same time, small parts are manufactured separately. Crankshaft. Made of thick sheet metal, forging to withstand high torque. Pistons and connecting rods, made of aluminum alloy to make it light but strong. Valves and camshaft, these control the air and exhaust flow. Assembly line. On the production line, robots and technicians begin assembly. Place the crankshaft in the block, followed by the pistons. Place the gasket and cylinder head cover. Install the turbocharger and fuel injection system. Testing the heart of the engine. The assembled engine is not yet installed in the machine. Cold test. Spin the engine without fuel to check oil pressure and smoothness. Hot test, or dyno test. Start the engine and measure horsepower and torque. If there is any unusual noise or abnormal heat buildup, the engine will be removed for inspection. Fuel injection system is a technology used to inject fuel into the engine in a very precise amount and at the right time. It replaced the carburetor to make the engine more powerful and consume less fuel. Here are its main parts and how they work. 1. Core components. Fuel injector. It is an electrically controlled valve. When it opens, it sprays fuel out as a mist so that it is easy to ignite. Fuel pump. Pumps fuel from the tank to the engine at high pressure. ECU, electronic control unit, controls how much fuel to inject and when based on data from sensors. Sensors measure airflow, engine temperature, and gear position. 2. Common types. There are currently 2 main types in use. Multi-point fuel injection, MPFI. The injector is located in front of the intake valve of each cylinder. It injects fuel into the air before it enters the combustion chamber. Direct injection, DI. This is the most advanced technology, like GDI or common rail diesel engines, where the injector injects fuel directly into the combustion chamber. This provides the most power and fuel economy. 3. How it works. 1. Measurement. When you shift into gear, a sensor measures the amount of air flowing in and sends it to the ECU. 2. Calculation. The ECU calculates how much fuel to use to achieve the air-fuel ratio. 3. Injection. The ECU sends an electrical current to the injector. The injector nozzle has very small holes that will spray the fuel in the smallest detail. 4. Combustion. The fuel, which is the smoke, mixes with air and is ignited by a spark plug for gasoline or by pressure for diesel. 5. Advantages. Economical. Does not waste fuel because it is injected according to actual needs. Powerful. The engine burns well, making it powerful. Environmental. Reduces toxic fumes from the exhaust pipe. The quality of Komatsu excavators is recognized worldwide as the gold standard in the heavy machinery industry. The reasons for this brand's popularity are based on several key points. 1. Vertical integration. Unlike other brands that purchase engines from other companies, such as Cummins or Isuzu, Komatsu manufactures all core components in-house, including engine, hydraulic system, and electronic control system. Special feature: when all components are designed and manufactured by one company, it makes the entire system work in perfect harmony, perfect match, increasing work efficiency and reducing damage. 2. Durability and service life. Durability. Komatsu machines are designed for the heaviest work, heavy duty. Strong frame. The use of high-quality steel and robot welding technology makes the body and arm, boom or arm, resistant to cracking, even when used in rock construction. Protection system. All electronic components and hydraulic hoses are tightly protected from dust and moisture. 3. Smart technology. Comtrax. This is one of the strengths of Komatsu quality. It has a GPS system and sensors that remotely monitor the health of the machine. The machine owner can know fuel consumption, location, working hours, and warning signs before damage occurs. Predictive maintenance. 4. Save fuel and torque. Fuel efficiency. Despite its high power, Komatsu's hydraulic system is designed to reduce energy loss. It has a variety of work modes that allow the driver to choose the power to suit the job. For example, economy mode. 5. Resale value. Resale value. Due to its reputation for durability and easy availability of spare parts, Komatsu excavators maintain the best value in the used machinery market. Even after many years of use, they still have high resale values. In short, if you want a machine that is strong, fuel efficient, and has advanced technology, Komatsu is the top choice.